Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem combination sum. So the problem statement says that given an array of distinct integers, candidates and a target integer target, return a list of all the unique combinations of candidates where the chosen numbers sum to target, and we may return the combinations in any order, and the same number may be chosen from the candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. The test cases are generated such that number of unique combinations that sum up to target is less than 150. So this is just for time complexity. So now the problem statement says that we are just given an array candidates where some integer elements are given and a target is given. Our task is to uh, find all the possible, what we can say, subsets, we can say, that that uh, that sum up to the target. All right, but the twist is that we can choose the elements infinite number of times. All right, so we have uh, we have uh, the flexibility of choosing any element infinite number of times. So we just have to return that power set or whatever we say. So in the example one, if candidates are given 2 3 6 7 and target is 7, so we can see the only possible way is using 2 two times and 3 one time. This will sum up to 7, and choosing just 1 7. So we can see that these two possible sets are coming, and we have to just store them into a big set, into a set, and we will just return it. So we can see that this way this question we have to solve. So how we can solve this? So we all know that we all know that we have options that either to choose this element or not. So if we choose this element 2, then what? If we choose this element, so we will, our sum will, let's say our target will reduce by uh, 2. Now we have to find 5. Now we have also the flexibility to choose this 2 again. All right, so in this case, if I say that if I have to solve this problem, I will use the pick and non-pick, and I have made the recursion tree also. So I'm taking a smaller example to explain well, so that recursion tree can be small also. So I have taken the candidates array 1 comma 2 and target is 4. So what are the possible answers here? First of all, I will see that possible answers are using 1 4 times, so this will also sum to 4. Using 1 2 times and 2 1 times, this will also sum to 4. And then 2 comma 2, this will sum to 4. So these are the three possible answers. Now I have options that either to choose. First of all, I will I will be here, and I will say that first of all I want to choose 1. I have option to choose 1 or not. So if I choose 1, now my subset or my current set, I would say that this will be 1, and my target will be reduced by 1. So my target will be 3 now. And now I have flexibility that I have infinite number of elements. So this set is like this. Here it is given 1 comma 2, but we can imagine this as I is equals to uh, we can imagine this as 1 comma 1 comma 1 up to infinite, and 2 comma 2 comma 2 up to infinite number of 2. So I have flexibility. So I'm saying that now I want to choose this one again. So I will say that my I is 0 again now. Now, so I will be 0 now. And if I do not choose this, if I do not choose 1, now my target will remain 4 and my set will be remain empty. Now if I do not choose this 1, I will move ahead. So now my I will be equal to 1. I will be moved now. Alright. So now if I pick 1, then I want to I have two options, either to pick this 1 again, or to not pick this one. Alright. So if I pick this one again, so my set will become 1 comma 1. Alright, my set will become 1 comma 1, and now my target will become 2, because already it was 3 and reduced by 1, it will become 2. Now again I have the flexibility to choose this one again. So again I will say that if I want to choose this one again, so it will become 1 comma 1 comma 1, target will become 1. Again I want to choose 1, so this will become 1 comma 1 comma 1, and target is 0. And this is our base case, target is 0. If target is 0, it means that we have found a potential a possible answer, that will sum up to target. So now this will be our base case, and we will return. We no need to go further because we have found our target. So target is 0. It means that we are done, and we will return. So I have found one answer, 1 comma 1 comma 1, which is summing up to 4. That is target. Now again here, if you do not choose this, so if I do not choose this, I will move ahead. I is equals to 1. All right. So now first of all, if I do not choose this, this will remain same. Target will be 1, and I is equals to 1 now. So now it is not fulfilling. We have to go again. Now I have option to either to choose this I is equals to 1 again or not. So before choosing I is equals to 1, if my target is 1, and at I is equals to 1, at I is equals to 1 index, this is 2, and if I choose 2, so my target is 1 and the index element is 2. So if I choose 2 there, then my capacity is 1. Alright, my capacity is 1, and I have found an element greater, that is 2. So I cannot choose that element. It will exceed my target. So I will just say that I will not choose, I will return from here. So this is our also base what we say, that we move only when index element is less than or equal to the target, then only we will move ahead. All right. Now if I do not choose this, my I will be increased. So I is equals to 2. So this is exceeding the n. So this is also our base case, that if I is greater than or equal to n, then we will just simply return. Similarly here also, if target is 2 and I is equals to 1, I have option to choose this I is equals to 1. So here I can see that if I choose 2, so this will sum up to 4 and target will be 0. And as soon as we find target is equals to 0, we will just say that we have found one answer. We will just store this 1 comma 1 comma 2 into any data structure, or mainly we will use vector of integer 2D array, and we will store there. So all right, so we will store it. Now while returning, I will also check the other case. This will say that if I am not choosing I is equals to 1, I will move ahead. I will choose I is equals to 2. I is equals to 2 is going out of bound. I will just return. And here also now we are here, and if I do not choose this element, target is 3. So similarly, we will just go deeper into the array and check whether I can choose I is equals to 1 element or not. It will become 1 comma 2, and again my target is greater than 0, so I can go ahead also. So I have options to choose or not choose. So here at 1 comma 2, target is 1 and I is equals to 1. I have option to choose I is equals to 1. If I choose I is equals to 1, so this will be 2. I is equals to 1 element is 2, target is 1. It is the target is 1 and index element is 2. Target is less than the index element, so we will not go there. We will return. And if I do not choose this, then I will be equal to 2. This is going out of bound. We will return. Similarly here also, that if we see that I is equals to 2, it is out of bound, we will return from here. Now if I come here and check, check here that target is 4 and I is equals to 1. So I have option to choose I is equals to 1, or I have option to not to choose I is equals to 1. So if I choose, then the set will be like containing only 2, and target will be reduced to 2, and here my I is equals to 1 only, and again I have option to choose the same element 2 or not to choose. So if I choose 2 again, so this will become 2 comma 2, and target will become 0, and I will just say that I found an answer, I will store it and return. And if I do not choose it, I will move ahead and this will go out of bound, I will return. Now similarly here also, if I do not choose I is equals to 1, it will go out of bound, because this was I is equals to 1, and it will move ahead, this I will come to, and I will return because it is out of bound. So at last, when our recursion will be completed, we can see that we have stored our answers 1 comma 1 comma 1 comma 1 and 1 comma 1 comma 2 and 2 comma 2. So these are our answers. So we can see that we have found the answers. All right, so here also the answer is correct now. So the main logic for this was just to pick or not pick, and if we are picking, we can again pick. If we are picking, then we can again pick. If we are picking, we can again pick, and if we do not pick, we will move ahead our index. So this was the just logic, and base case was just that if target is 0, or if index is out of bound. And yes, we will also keep in mind that the index element which we are choosing, so if we are choosing any index element, we should check that if that index element is less than or equal to the target or not. All right, that capacity capacities of I mean capacity, let's say capacity is 10, and we have found the item of 11. We cannot store this item into this bag. All right, because its weight is 11 and the capacity of the bag is 10. We cannot store. We can only store elements less than or equal to 10, with weight less than or equal to 10. All right, so we will just handle this. So if I go and implement this, simply first of all I will just find the size of the candidates array. So now what I will do, I have to store the subsets. So first of all I would like to create the, let's say current subset is current, and I have to return the answers. So I will store the result in a res, let's say. Now I will call my solve function, and first of all I will send the index 0, and my current subset is curr, and resultant vector is res, and yes, candidates array also, this candidates array also, and target also we have to send, and let's say I'm sending n also. This will help me not writing candidates dot size again and again. And at last, when I will fill my resultant vector, I will just return result. Now I have to write just the solve function. So solve function is returning nothing, so but it is taking what, index, and then this current, and don't forget to pass by reference, and resultant by reference, then candidates array, then target candidates, and then target, and then what, we were sending n also. So now what, first of all, what was our base case? So base case was if target we found is 0. Now target, if we found 0, what we will do, we will just push back the result, push back the current into the result, and we will just return. And what was the another base case? That if index is out of bound, and in this case we just return. And next, now if we pick that element, so if we pick that element, and we will pick only when the element, that is this candidates of I is less than or equal to the target, then I will say that okay, now you can be in my set. So current dot pushback this candidates of I, and now I will call for the next recursion. And when I will call for the next recursion, I will say that take this I only, because if we pick any element we can pick again that element, so I will be the same. And then what I was passing, that current subset, that resultant, that candidates array, and target is what we are taking that element. Now our target will reduce to target minus candidates of I, and at last n was also passing. And now once we have checked for the pick element, we have to check for the non-picking. So now in this case, first of all I will remove that element. So I have taken this one. Now if I have to check, if I check for the empty, I have to remove this one. So we all know this case, we have to pop back. Now for the not picking case, not picking case is simply just we have to go and check for the further. Current will remain current, result will remain result, candidates will remain candidates, target will be now the target only. All right, because we are not taking that element. Now what will happen, this will now store the resultant vector, and if we are passing by reference, then resultant vector will be ready. And if I submit this and check if we haven't missed anything, and now if I submit this and check if we are able to pass all the test cases or not, so we can see that we have solved this problem now successfully. And if I tell you the space and time complexity, so time complexity, what I think, or that's correct, that see, we have options. So here we have only two elements, so we have options here, either to choose this element or not. So here we have two options, here also we have two options. So basically we have 2 to the power n, where n is the size of the nums array, candidates array. So we have the option to choose this or not, two options. But we can see that 2 to the power n combinations will be there. But what do you think, that if we are picking this element, then we can again pick, then we can again pick, then we can again pick. So I would say that in general I can say that how many times we are picking it, non-picking it, until we find the answer. So there is no straightforward any variable, or we, so I am saying that I will say that time complexity is 2 to the power 2, that many time we are picking or not picking any element. All right, so if elements were not infinite, then 2 to the power n was correct. But here we have flexibility to choose any elements infinite number of times. So how many times we are choosing, that I am taking t. So time complexity is 2 to the power t, and whenever we find any answer, we just store this 1 comma 1 comma 1 comma 1 into our data structure. So that's why for storing this length, that is here it is 4, so for storing this 4 length array into our data structure, this will take big O of 4 time complexity. So if average length of all the combinations we find is k, so at last we are just pushing back So that's why this time complexity of pushing back I am taking k. So at max I can say approximately that time complexity is coming 2 to the power t into k. And space complexity, we can clearly see that we are just storing the resultant vector. We are just storing the current subsets and resultant vector. So this will be what? So so if we have x number of combinations, so time complexity will be x into average length of every set. So average length of every set is k, and there are total number of combinations x. So it is not guaranteed. That's why I'm saying that it's x into k. Big O of x into k. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.